Welcome to Engage Math, Lesson 1, Problem 6. And we are continuing our work with solving equations, but this time we are going to have equations with fractions and decimals. I am a huge fan of getting rid of the equations that have either decimals or fractions in them, and not getting rid of the whole equation, just getting rid of the decimals and fractions to make the equation easier. So how do we do that? Well, let's start with 6a. So this time we have decimals, and the most times that, or the most decimal places in any one of the terms is two decimal places that we have in this term and in this term. So we can, a lot of people think of it as, oh, let's just move the decimal 2 positions to the right. If we do that to every term, we're keeping the equation equal. And that's actually true. But the reason that you can do that is because what you're really doing is you're multiplying through the entire equation by 100. And that moves every decimal 2 to the right. So we're doing the same thing to the left and the right side of the equal sign, so we can do this. So let's start with that 0.6, which we know is 6/10, and we start and we get 60 plus 21k, because we're moving every decimal 2 to the right as we multiply through by 100, equals minus 3 equals 120. All right, now it's just a regular old equation. I am going to combine the 60 and the minus 3 together. So I have 57 plus 21k is equal to 120. Subtract 57 from both sides. We're doing the same thing to both sides, so we can certainly do that. So 21k is equal to, and think about when you subtract 57 from 120, because I know we're encouraging some good mental math here, the difference between those two is 63. So 120 minus 57, you could always write it out, but I love the mental math, equals 63. We divide both sides by 21. Not by 2k, by 21. So the 21s cancel, and we have k equals 3. Okay, let's move on to 6b. So in 6b, it's a very similar problem in that we have something in there we don't love, which is fractions. Not that we don't love fractions, just that it's good to get rid of them if we can. Okay, so let's multiply through by the least common denominator of 2. So I'm going to put a little 2 on the outside here, and just off to the side, I'm just going to kind of remind you that 2 times 1/2 really means 2 over 1 times 1 over 2, which is just 2 over 2, or 1. So when this 2 distributes to that first term, we just get m. I'm going to write 1m just so you know what happened to the 1. So it's 1m, but we can write m, minus 2 times 8, because we're distributing that 2 to every term, so minus 16. And then we distribute the 2 to the negative 2, and we get negative 4. Add 16 to both sides. And we now have 1m. I'm just going to now write it as m. M equals 12. And that's all we can do. But think of how nice it was to get rid of those fractions right off the bat. So I think it really helps to do that. Let's look at the next one. Here, our common denominator is 5. So I'm going to multiply the entire fraction through. Let's actually kind of put the entire equation through by 5. I'm going to put the 5 right here above the C. So 5 times 13, 65. So 65 equals 20 plus, and now remember, 5 times 3/5. You don't actually have to do 3 times 5 and get 15 and divide by 5. You could just think of the 5's cancel, so we just get plus 3p. Now we're going to subtract 20 from both sides, and we get 45 equals 3p, divide both sides by 3, and we're going to get, I'm going to put the p on the left, but either way, p equals 15, and we are done. All right, let's go to the last one, which is a little bit trickier because there's 3 different denominators, 2, 6, and 3. So what we're going to do is we're going to take the least common denominator, the number that that all 3, 2, 6, and 3 go into evenly, which would be 6. So that's like the least common denominator, or sometimes called the least common multiple. We can think of it that way. So I'm not going to show all the work this time. 6 times 1/2. You're just multiplying 6 times 1/2. So we get 3 plus the 6 times the 5/6 If you want to think of it as 30 over 6 and then divide and get 5, fine. But the shorter way of thinking of it is the 6's will cancel, like this 6 and this 6 will cancel when you multiply because they're just equal to 1, because one's in the numerator and the other in the denominator. So we're just left with 5c equals, and now you can either think of it as 6 times 2 is 12, divided by 3 is 4, or you could think that the 6 here over this 3 reduces to 2, and you have 2 times 2. Either way, we're going to get 4. Always, when you multiply through by that least common denominator, all the fractions are cleared and your equation becomes so much easier. So now I'm going to subtract 5c from both sides, and we're going to get 3 equals a negative c, which we can write it as negative 1 if we want to. We're going to divide both sides by negative 1. The reason it's by negative 1 is there's really a negative 1 right there. It's just not written. But that is going to give us negative 3 is equal to C, because then we have C completely alone. And we're done. All right. Thanks for joining us here today at Engage Math.